But this is how I did it. I said, okay, what is the label for the y-axis? Gibbs. Okay, or the letter G. How about the x-axis? Reaction, progress, coordinate, whatever you want to label it as. Okay, and then I went like this. Tell me when you want me to stop and draw the line for reactants. Okay. Now tell me when to stop. Tell me when to stop on the other side. Okay, so we have reactants, we have products, and then here is how we get our delta G. Okay. So we should also have delta G labeled. Products minus reactants is going to be greater than 0. So this is what everyone should look like. Right. And then which part of this table here are we always going to have a non-spontaneous reaction or always have a positive delta G? Bottom right, okay? Always non-spontaneous. And so the way to think through this one for yourself, delta G equal to delta H minus T delta S. Okay. If this were a positive number and you were subtracting a positive number, no, a negative number. Subtracting a negative number is a positive number. This would always have to be a positive number. Okay. So this is a direction of unfavorability would be having a negative delta S and having a positive delta H. So when you have negative delta S, this is a very unfavorable. Having a positive delta H, this is unfavorable. It will always be non-spontaneous. Okay. How do you get solid ice to turn into liquid water? What do you do? Let's think, we're at isobaric. This is Gibbs. So temperature is our only thing we can consider here, okay? So what do I do to T? I raise it, all right? What is going to be the sign of delta H for melting the ice into water? Am I putting in heat? You don't think it's all? Delta H is going to be positive, okay? It's absorbing heat from the environment. It's taking in heat in order to melt, okay? This is an endothermic process this way, okay? Are we increasing the disorder of the molecules? So what's the sign of delta S? Positive. Okay. So for positive delta H and positive delta S, this is spontaneous. As T gets sufficiently large, right? Raise temp high enough, this would become spontaneous. In this case, we know what T we need to go above to get ice to melt. What about going the other way? Yes. Yes.
When water freezes, it's exothermic.
Yes. That is what I am suggesting here. That the sign of enthalpy when water is freezing and going the other direction is now releasing heat to the environment. So yes, when we are having more order, okay, as our water is freezing, okay, and this is an exothermic process, we now have, this would be spontaneous. We know that water would freeze as temps get sufficiently low. Okay, so you should be filling in the rest of your table to match. And then if you flip it over on the back, go ahead and use that table. Please circle the terminology that matches all of these signs. Okay, so it has sign of delta G, delta H, and delta S. And you're being asked to circle whether it's exothermic, endothermic, exergonic, endergonic, or you couldn't tell, and entropically favorable or not. Okay, so go ahead and do all your circling in that far right column.